Welcome to Shiksharthi, and today's our topic is exercise problems on probability, and for you I'm going to solve exercise 15.1 page number 308. So hope you have seen my previous videos which were briefing you the concepts on probability. Now let us see the questions here. Probability of, there are fill in the blanks. The first question, you have your books with you. See the first question from the book. Probability of an event E plus probability of an event not E. So this is something like probability of happening of an event, I would say. Probability of happening of an event plus probability of non-happening of an event is how much? We know this is, according to properties, it is 1. Happening plus non-happening. So you can see happening of an event, not happening of an event E is equals to how much is the question, which is 1. Second question, the probability of an event that cannot happen. Like if I am rolling a die multiple of 7, multiple of 9. We don't have multiple of 7 or 9 in a die. A die will have numbers from 1 to 6. So 7 is an impossible number. Any multiple of 7 is an impossible number. So in such case, the probability will be how much? 0. And such events we call it as impossible events. Okay, this we have already discussed in our basics. Next one, the probability of an event that is certain to happen. Definitely it should happen. Then the value will be how much? 1. Such events are called as sure events, or in the question itself you have a word here, certain events. So sure events or certain events which will definitely happen is called sure or certain event. The sum of the probabilities of an elementary events of an experiment is, say for example, if I am talking about a dice, and what are the total outcomes of a die? 1, 2, 3, 4, 5, 6 are the total outcomes, and the probability here of getting 1 is 1 by 6, 2 is 1 by 6, 3 is again 1 by 6, 4 is 1 by 6, 5 is 1 by 6, 6 is 1 by 6. Sum of all these is equal to 1 because all the phases have equally likely chances of coming. So every one of the event, every elementary event, like elementary event 1, elementary event 2, elementary event 3, equally chances are there of 1/6. So total sum will be equal to 1. So the answer for this question is 1 for sure. Next, the sum of the events is greater than or equal to 0, less than or equal to 1. If you see the properties, we all know that probability of happening of an event always lies between 0 and 1. It is greater than or equal to 0, less than or equal to 1. That's what the same question we have here. So these are the 5 fill in the blanks you have in the first question. So let us move on to second question, all of you. Which of the following experiments have equally likely outcomes? What is equally likely outcomes? When I am tossing a coin, getting head or getting tail have equally likely chances. If it is a unbiased coin. So if it is an unbiased coin, chances of getting head is same as chances of getting tail. And previous example, the dice, chances of getting 1 is same as chances of getting 2 is same as chances of getting 3, 4, 5, 6. So all 6 phases have equally likely chances of getting it. So what is meant by equally likely? Every event should have same chances of coming up. So here the first question, a driver attempts to start a car, the car starts or does not start. Now you may think, yes, it is of course like it may start or it may does not start, but there can be other things also. Here majority of the time we know our cars usually get start, they don't get stuck. I mean they don't start is a rare cases. If there is any engine problem or any special situation, then only it is possible to say that the car may not start. Otherwise usually it starts. Or sometimes eventually it may also happen like it gets start but instantly it gets stop as well. So you cannot say it is completely start or completely stop. So we have lot more other situations other than just getting start or stop. So we cannot consider this to be equally likely. So I'll take this as no. Next one, a basketball player or player attempts to shoot a basketball, she or he shoots or misses the shot. Again, you may feel like it may shoot or it may not shoot. I mean it may miss the shot. But here there are other consequences. Like suppose if he shoots the ball in a basket, but it may go some foul in that case. So that can be a special case here in that case, right? So you may attempt it properly, you did everything right, but maybe the situation, the line, the area from where you have to throw, or you are throwing beyond the line, you cannot stand this. I mean, there are certain rules which we need to follow. So such rules are not described here. Just shooting the ball in the basket or not in the basket is not only the two situations. There can be some other situations as well. So again, this I consider to be wrong. Next one, a trial is made to answer the question and it should be right or wrong. Yes, of course, you cannot take an option called right as well as wrong simultaneously. It is not possible. So it should go either right or wrong. So this is called equally likely here in this case. Same like a coin, head or tail kind of a situation. And again, a boy is born, it is a boy or a girl. I mean, a baby is born, whether it is a boy or a girl. So we all know that there are only two things. If it is a boy, then it is not a girl. If it is a girl, it is not a boy. So in such case also it is said to be equally likely events. So this also I consider to be equally likely. Now let us move on to question number 3. Why is tossing a coin considered to be a fair way of deciding each team should get the ball at the beginning of the football game? Now we all know majority of the games, whenever we are starting a game, we toss the coin to know which team will initiate or start. For example, in terms of football, who will have the first kick? In case of a cricket, who will bat first or ball first? We decide on the basis of the tossing a coin. Why coin is taken here? Because the coin is an unbiased device where we can get a decision whether it is going to be head or tail, and head to be given to one team, tail to be given to another team. So we can get a fair deal. And since head and tail here are equally likely, so any of the team can win. So it is a best way to decide who will have the ball first in the football game. So this is what you need to write down in your words. Fair enough? Next. If I look at the next one, which of the following cannot be the probability of an event? Sir, we all know probability of an event lies between 0 and 1. So in these 4 options, anything which lies between 0 and 1 have to be the answer. The value of this is 0.66, which lies between 0 and 1. It is minus 1.5, definitely it is not between 0 and 1. 15% is 0.15 in the decimal, easy to understand. Again, it falls between 0 and 1, and 0.7 also falls between 0 and 1. So my clear answer here is minus 1.5. Question number 5. Probability of happening is given. Question is to find non-happening of an event. We all know probability of happening of an event plus probability of non-happening of an event is always equal to what? 1. Question given this 0.05 or 5%. P of E dash is how much? So we can find out P of not event or not E is 1 minus 0.05, which is going to be 0.95 is what I get. 0.95 is what I get. So probability of happening plus non-happening of an event, this itself is sufficient to answer the question here. Very important. Without writing that, please do not write the answer. You need to know in what way it has come to you. Okay. Next question, all of you. Question number 6. A bag contains 11 lemon flavored candies only. So all the candies are lemon flavored. Now, Malini takes out one candy without looking into the bag. What is the probability that she takes out? An orange flavor candy. You can observe in the purse, all the candies have lemon flavor. You don't have orange flavor in that. So getting an orange candy is 0 possibility or impossible event, you can say. 0 is the answer for this. Next, getting a lemon flavored. So all these toffees or all the candies are of lemon flavored only. Any one you draw, that will be definitely a lemon one. So here this is said to be a certain event in this case. So if you have a basic ideas, then easily we can handle such questions here. Next, it is given that in a group of 3 students, the probability of 2 students is not having the same birthday is 0.992. What is the probability that 2 students have the same birthday is the question. It is given that the group of 3 students, right? And the probability of having two students not having the same birthday, something like this. P of E dash, let us take, is 0.992 is given to us. What is the probability that the 2 students have the same birthday? Here is started with not having the same birthday, and the question is to find have the same birthday. So question is to find the P of E here in this case. We all know P of E plus P of E dash is equal to 1 as well. P of E plus 0.992 is equal to 1. Then P of E must be equal to 1 minus 0.992, which is 0.008 is the required answer. So what is the probability of 2 students having the same birthday is 0.008 is the answer for you. Fair enough? So this is again the rule to be used here in this case. Next one, friends. A bag contains, red balls 3, black balls are 5. A ball is drawn at random from the bag. What is the probability that the ball drawn is red and the second bit is not red? Now if you see the total number of balls are how many here? 8. 8 are the total. And the question first bit in this, getting a red color, probability of getting a red ball. And you can see how many are in favor. Total number of red balls are how many? 3. So favorable are 3 out of the total how many? 8. So probability of getting a red color is 3 by 8. If you want second bit, from the first bit only we can get it. Probability of not getting a red is the question. Or the same thing can be observed. If we don't pick up red, definitely it should be what? Black. So this is probability of getting a black color. So I'll take this in 2 methods, friends. 1 minus probability of getting red is the method. That is 1 minus 3 by 8, and your answer have to be 5 by 8. Or directly you can find if it is not a red, then definitely it should be black. So number of black balls are how many? 5. 5 are in favor. So 5 out of 8 is a direct answer for this. So either you go by this method or this method, the answer have to be same. So just pair methods, anything we can opt for here. Next one. A box contains red color, which are 5, and white color you can say are 8. We have green color also, which are 4. One marble is taken out of the box at random. What is the probability that the marble taken out will be red, white, not green? So I'll start with the first one, red. And before that, I need to know the total number of balls in the box. So if I add them, I'll get the total, which is to be 12 and 5, that is 17 balls we have. Now suppose my first question, probability of getting a red color is equals to, how many red are there here, friends? 5. Out of the total, 17. And what is the definition of probability? Favorable out of total. So it is 5 out of 17 is what I need to write down. So in words you can start writing, given the number of red are 5, total number of balls are 17, probability of getting red is 5 out of 17. And we don't have any calculation on this, so 5 out of 17 is the answer. Second one, getting a white color. So probability of getting a white color, number of white color balls are how many? 8. So you can say 8 out of total how many? 17. So 8 are in favor because 8 balls are there. 8 are in favor out of total 17. Now the question is not green. So green complement is what I need to do. Again, 2 methods. Find what is the probability of getting green and then take a complement of it. That is one method. I'll show you that. 1 minus probability of getting green, I'll do it here. This is one method. So here you tell me 1 minus probability of getting green is how much? Green balls are 4 out of 17, and my final answer is 1 minus 4 by 17 have to be 13 upon 17 is the answer. This is one method, probability of not getting a green, Or else, if it is not a green color, imagine if it is not a green color, then it should be red or white. So you can directly find not a green means it should be red or white. So how many red and white together we have? Total 5 plus 8, which is 13. So 13 out of 17 is what we have. So not green means it should be either red or white. So we can take that as an answer for this. Okay. So how do we do this question, friends? Completely closing this question here. Probability of getting a red or white. So we'll add both of them. Red chances are 5 by 17 plus white chances are 8 upon 17, and that is equal to 13 upon 17 is what you get. So this is a method to find out this. So if you want to write any statements, please do that here like this. Next one, a piggy bank contains, next question all of you, a piggy bank contains 50 paisa coins. So you can write the bifurcation given to us. 50 paisa coins are 100, 150 paisa coins are there. Next, 50 1 rupee coins are there. So 1 rupee coins are 15 number. Okay. Then 20 2 rupee coins are there. Fine. 2 rupee coins are 20 here. Next one, 10 5 rupee coins are there. 5 rupee coins, denomination 5 rupee coins are 10 over here. So this is denomination we have, and this is number of coins we have here. So if I get a total, how many number of coins are there? 100, 150, 170, 180. I have total 180 coins here with me. Okay, number of coins are 100, 50, 20 and 10. I just added all of them. I got the number of coins to be 180. Now what is the question, friends? If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paisa coin? So if you say probability of getting 50 paisa coin will be equal to, how many 50 paisa coins are there? 100. And how many are total number of coins, friends? 180. So if I take this by 20 table, I'll get 5 upon 9. So getting a 50 paisa coin, the fallen coin, if it is a 50 paisa coin, then definitely it is 5 upon 9. Next one, will not be 5 rupee coin. Sir, if it is not to be 5 rupee coin, how do I write? 5 rupee coin, and it should not be a 5 rupee coin, is said. So 1 minus probability of 5 rupee coin you should find out. Find out the possibility if it is a 5 rupee coin. How many 5 rupee coins we have here? 10. So you can say 10 are there. So this have to be 1 minus 10 by 180. 0, 0 cancel. This have to be 17 upon 18 is the answer. You can also write, if it is not a 5 rupee coin, this should be the 50 paisa coin or 1 rupee coin or 2 rupee coins. So total other than 5 rupee coins we have 170. So 170 coins out of 180, 0, 0 gets cancelled. You get 17 upon 18 as the answer for this. We'll switch to next question all of you. Gopi buys a fish from a shop from his aquarium. For his aquarium, the shopkeeper takes out one fish at random from the tank containing 5 male. So here male fish are 5, female fish are something like 8. Total number of fish are 13. Okay, in that tank. Now the question is, what is the probability that the fish taken out is a male fish? So probability of getting a male fish. How many male fishes are there? 5. So probability of happening is 5. Favorable are 5. Upon total number is how much? 13. So answer have to be 5 out of 13. Please also every time, since it's a marks oriented question, 1 mark or 2 mark, whatever it is, you just write probability of male fish is equal to number of favorable. This you should always write upon total number of fishes. Okay, so this is how the favorable is something called as male fish, and total number of fish are male plus female in total. So that is how you can write this. Next one, a game of chance consisting of a spinning on row which comes to rest point at one of the numbers. Okay, so you can see there is a pointer here and the numbers are rotating, spinning here. So we need to know what is the question, and these are equally likely outcomes. What is the probability that it will point at 8? So this pointer should point at 8. 8 is one of the event which is equally likely with the other events. Like 1 have equal chances, 2 have an equal chances, 3 have an equal chances. So 8 out of 8 total number of outcomes possible, 8 is 1. So probability of getting 8 is equals to 1 out of 8 is the answer for this. Second one, an odd number. You see, there are total 8 natural numbers. First 8 natural numbers are given, and we know in that odd numbers will be 4. So probability of getting an odd number is 4 out of 8, which is half the chances. We can also directly say this because half of the numbers are even, half of the numbers are odd. Definitely probability of getting an odd is half. Next one, getting greater than 2. How many numbers are greater than 2, my friend here? Getting greater than 2 must be 6 out of 8, which is 3 by 4 is the answer for this, 3 by 4. And lastly, a number less than 9. All the numbers are less than 9, so it is a certain event. So here it should be less than 9, have to be 8 out of 8 are less than 9, and that gives you 1. So practice this. Again, I solved up to 12 problems. In my next video, I'll try to complete all the remaining rest of the questions. Thank you all.